Hello students. So let's solve next question. F and g functions are defined on real numbers. F of x is given as mod of x. G of x is given as greatest integer function. Okay, less than or equal to x. Then F composite g you have to find and g composite f you have to find. Now this is 5 by 2 is nothing but 2.5, right? So the greatest integer number which is less than or equal to this is 2. Okay. So first we'll write f composite g of 5 by 2. Okay. So this is f of g of 5 by 2. So g of x is greatest integer function. Value is 2.5. Okay. Then mod of this. So this is nothing but 5 by 2. Okay. What about g composite f? G of f of minus root 2. So this is mod of minus root 2. So this is g of root 2. Okay. So this is greatest integer function. Okay, root 2 is around 1.2 or something. So the greatest integer function less than is 1. Okay. Next question is you have to prove that the inverse of a square matrix, if it exists, is unique. So here you can prove it by contradiction method. That is, you have to take two inverses. Suppose we have B and C as the inverses of A. Okay. Then according to the definition, we can write AB equal to BA equal to I, identity matrix. Same way AC equal to BC equal to I. Okay. So we have to prove now that B is equal to C. So start with B. B you can write it as B into I. Correct? So I will substitute I as AC. This I've written CA. Okay. So I can write it as, I want here identity, right? And C. So I'll write I as AC. So this I can write it as BA into C. BA is again I. So this is C. So B is equal to C. So if it exists, then inverses are equal. Okay, unique inverse. This proof in detail I have done during the chapter determinants, matrices and determinants. Okay, inverses is there in determinants. So you can go there and check the detailed proof. I'll link this in the description, that chapter. Okay. Next question is three yarns are given, each containing red and white balls. Yarn 1 contains 6 red and 4 white balls. Yarn 2 contains, so I'll write here, contains red and white. 6, 4. Then this contains 2 red, 6 white. Yarn 3 contains 1 red and 8 white. And yarn is chosen at random and a ball is drawn from that yarn. The ball drawn is red. Find the possible probability that the ball is neither from yarn 1 nor from yarn 2. So we want this probability of finding probability from yarn 3. Okay, it should not be from yarn 1 or 2. So should be from yarn 3. And our event, that is A event. Now looking at the question, you can identify that that question is Bayes theorem, based on Bayes theorem, right? So these are our events, E1, E2, E3. That choosing a drawn ball is drawn from the yarn. The ball drawn is red ball, drawing a red ball. This becomes our event A. Okay, so here three possibilities are there. So if you are choosing, probability of selecting E1 will be 1 upon 3, correct? Same way E2, same way E3. Now you have to write probability red ball, and it is from E1. Okay, so now here total balls are 10, right? Out of which we are choosing a red ball, so 6 over 10. So this is 3 upon 5. Then A over E2, 2 upon 8. So 1 by 4. Then E3, this is total is 9 and 1 by 9. Okay, so I'll write it here. Okay, now what we have to find? We have to find the ball is drawn. It is not from yarn 1, not from yarn 2. So it should be from yarn 3, and it should be red. Okay, so applying Bayes theorem, you will get P of E3 into P of A over E3 upon, then you have to add all three, E1 plus E2 plus E3 P over A over E3. Okay, substituting values, E3 1 by 3, A over E3 1 by 9, 1 by 3 into 3 by 5 plus 1 by 3 into 1 by 4 plus 1 by 3 into 1 by 9. Now here you can take common 1 by 3 from the denominator and also from the numerator. So this gets cancelled. Okay, remaining is, this is 1 by 9. This is 3 by 5. 3 by 5 plus 1 by 4 plus 1 by 9. Okay, now you have to do the cross multiplication. So this you can write 3 fours are 12 plus 5 upon 20. So this is 17 by 20. Then again cross multiplying, you will get 17 into 9. Right here, 9 into. this thing, okay, right here only. Plus 20 upon 20 into 9, 180. So I'll write it here. Okay, 20 upon 173. Okay, so this is the probability. Next question, they have given the dot product of a vector with vectors. These three vectors are there, and dot product with some vector. So that let that vector be some, say, p vector. Okay, xi plus yj plus zk. So p dot a is 3x minus 5z is equal to, it is given, -1. Then p dot b 2x plus 7y equal to 6. Then p dot c x plus y plus z equal to 5. Okay, now we have to find the vector, that is p vector. We have to find, that is the values of x, y, z we have to find. Okay, so from, we have to make use of these three equations. So from this equation you can write x as -1 plus 5z upon 3, correct? From this equation you can write, okay, so we have to put these two equations in this equation. So we can write z in terms of x and y in terms of x. Okay, so that we'll get the value of z. So this is z equal to -1 minus 3x upon -5. Then y is equal to 6 minus 2x upon 7. Okay, let's put these two equations in this equation. Suppose this is equation 3. So x minus, okay, I'll write like this, -5. Oh, this is y. Okay, this minus you can cancel, this will be plus. So cross multiplying, 35x plus 6, no 6, it is 5 6 30. Okay, you have to cross multiply like this, then multiply like this, and then you have to multiply it here. Okay, 7 21x, and this is 35 into 5. Okay, so this is 25 175. 35x minus 10, 25x, 25 plus 21 x, then 37. So 175 minus 37, 138. So x is 138 divided by 46. Okay, threes. So x is 3. Okay, x is 3, so put it in this equation z. Minus 10 by minus 5. 2. Z is 2. Y is 6 minus 6, 0. Okay. X is 3, Y is 0, Z is 2. So, our P is 3I 0J plus 2K. Okay. Next question is you have to prove the property of definite integral that I have done, okay, during the chapter. So you can just check over there. Next question is so x raised to p, y raised to q, this is given. You have to prove, that is you have to show this. Okay. So whenever raised to function is given, then you have to use log, right? So if I take log both the sides, then it will be log okay. So this is log a into b, log a plus log b, then log of a raised to b, so b log a. Okay. Here also log of a raised to b, so p comes here, q comes here. Okay. Now differentiating with respect to x, p log x, so this is p 1 by x plus q 1 by y, and then differentiation of y dy by dx. P plus q is constant, 1 upon x plus y, and differentiation of this, x is 1, y is dy by dx. Okay. So now you have to take the dy by dx terms together. So I'll write this. This will be what? 1 into whole of this. Then dy by dx into whole of this. So this term I'll taking this side. Dy by dx equal to remaining thing minus p by x. Okay. So taking common here, dy by dx q by y minus p plus q upon x plus y. P plus q upon x plus y, p by x. Okay. So multiply you'll get yq minus qy x into x plus y. Okay. So dy by dx is equal to and this whole term goes over there and becomes its reciprocal. So we have to write upon So this gets cancelled. Here minus px plus px, qi. So here we can write qx minus py, and this is py qx minus py. Okay, and this is also qx minus py, and this y and x. Okay, y and x. So this is what we wanted, dy by dx equal to y by x. Okay. Next question, a is given. You have to find the value of this. Okay. So a square you have to find separately. A square is a into a, right? Multiply both the matrices. Row into column. 2 2s are 4, 0, 1. 2 into 0, 0, 0, minus 1. 2 into 1, 2, 0, 0. 2 2s are 4, 2, 3, 2, minus 2, 2, 0, 1, minus 3, 0, minus 1. 2 1s are 2, 3, 1, minus 3. Okay, so we'll get 5, 9, 0, minus 1. Okay, so put this in this equation. 5, 9, 0, 2, 5, minus 2. 5 into a. So 10, 10, 5, 0, 5, minus 5, 5, 13, 0, plus 4 into identity matrix. So 4, 0, 0, 0, 4, 0, 0, 4. Okay. So adding and subtracting, we'll get 5 minus 10 plus 4, 9 minus 10 plus 0, 0 minus 5 plus 0, minus 1, minus 2, minus 5 plus 4, minus 1 plus 5, then 2 minus 5, 0, 5 minus 13, how 13? 15 it is, 0, minus 2, 0, plus 4. Okay, so this is 9 minus 10, 1, minus 1, minus 5, minus 1, minus 3, 4, minus 2, minus 10,